Hello again, it's Randy, and we are asked to do another machine problem. So for this one, we're going to write a script that employs the gradient function to determine the partial derivatives of the two-dimensional function f equals e raised to negative x squared plus y squared from x equal to negative 3 to 3 and y equals negative 3 to 3. Then use quiver to superimpose a vector field on a contour plot of the function. So for our code requirements, we are asked to express our function as an anonymous function, set the mesh grid to an interval of 25.25, set the contour line to 12 lines, and we're going to fill it, and of course use the color map jet. Okay, so we can work with that. We're going to set our function f, our anonymous function, equals to function of x and y, and then we're going to have an exponential negative x squared plus y squared. You want to add a dot there since I'm expecting we're going to be messing with matrices since we have a vector field. Next, we have an interval of 0.25. Let's set that as h equals to 0.25. And then we are going to define our x and y. So let's do just that. Let's make a mesh grid for, of course, our limits, negative 3 with an interval of 0.25h to 3. That's for our x. And then for our y, it's the same thing, 3. We're gonna want to omit that. So next, we're gonna express our function f into another function, z, y. And then we're gonna have figure to create a figure window. So what we're asked to do is contour this function. So we're gonna do just that. Contour. We have our x, our y, and our z. It is also asked to have a 12 line contour. So we're gonna do just that. 12. We're gonna run that just to check it out. And there you go. So since we are asked to fill them, we're gonna do just that. Luckily, MATLAB has our back and has an easy command for that. We just add f, meaning fill. There you go. Fill 2D contour plot, and then we're gonna run that. Okay, that definitely looks better. We might wanna limit our graph to certain values in order to make it look better. So we're gonna do just that. We're gonna assign our x limit. Let's see. I want to put that to negative 1.8, I guess, and then 1.8, and then a y limit of the same value, just to make it look better and keep its aspect ratio. So next, we're gonna hold on to this later on for obvious reasons. And then we are finally gonna use our gradient function. So since we have x and y, of course, we're gonna have to get partial derivatives of x and y is equal to gradient of z. That'll get our gradient. There you go. We're gonna want to omit that. So next, we're gonna be making a vector field for this. So to do that, we're gonna use the function quiver. And then we already have all our variables, so that's x, y, fx, and fc. And then we're gonna run that. Oh, sorry, fy rather. We're gonna run that, and there you go. That is what our function looks like with its vector fields. I'm gonna make that bigger just to make a better visual of it. And there you go. So that's all for this machine problem. I do think we've met the code requirements, and thanks for watching. I'll see you again next time.